A very warm welcome to Breakfast with Arup. Great to see lots of new faces, lots of very smiley faces from British land. So my name is Farah, I'm the Marketing and Communications Leader for Building Engineering London. And so to our speaker this morning. When Steve was a child, he was unwell one day from primary school, and his mother, who was a physics teacher, had a box which contained batteries, bulbs and switches. And one of the things he got to do as a treat was to make electric circuits. And this is what counted as a treat in Steve's early life. Steve also had a Ladybird book titled Magnets, Bulbs and Batteries. And this was his inspiration. By reading the book, Steve experimented with lemons, zinc and carbon rods out of batteries, and so began Steve's career in engineering at the tender age of 7. At 10, Steve, with his friends 2 doors up the road, built a telephone system, went through the back of people's houses and gardens. Attending Reading Boys Grammar School, Steve messed around with amplifiers, tape recorders and guitars, generally making a loud noise and frequently giving himself electric shocks as well. At university, Steve thought he was going to be an electronics engineer, but he found that a circuit diagram for an operational amplifier took him absolutely ages to understand, and how an amplifier actually worked. However, when he looked at civil engineering and structural drawings, he realized he could make sense of these immediately. Steve had a fascinating time at Exeter University, learning about jet engines and how to tune up sports cars, as well as dams, electric fields, and differential equations. Steve's final year project was about water outflow from the flood control dam at Newton Abbot. Steve's supervisors submitted the project to the Institution of Structural Engineers, and Steve duly won the National Prize for Model Analysis as a design tool. That should have been adopted, obviously, for flooding. Anyway, Steve also won the Institute of Civil Engineers Prize for the Best Civil Engineering Student of the Year. As he began applying for jobs, Steve turned up at our Bristol office half a day late for his interview. His car had broken down as he set off from Exeter, and he had to cut a gasket out of a cereal box and fix the car himself. Finally arriving at the Arup Bristol office, he was interviewed by one of our directors, who asked Steve what kind of engineering he was interested in. Steve said hydrology. His interviewer asked if he was interested in building structural engineering. Steve had not received many offers, and he decided he ought to say yes. So Steve started his career with us in 1985. Steve really has an impressive array of projects. His projects include Heathrow T5, Pan Bank Student Accommodation in Sunderland, HSBC Bank at Canary Wharf, Aspire Tower in Doha, and current commissions include 52 Lime Street, affectionately known as the Scalpel, Sagrada Familia, and 628 Bishopsgate. Working abroad, he's working with Heatherwick Studios on an astonishing hanging garden in New York City. So without further ado, I'm really very happy to introduce the wonderfully disarming Steve McKechnie. Thank you, everyone.
Hello. Before I start this morning, I think we should all just take a moment to acknowledge and remember the death of David Bowie. To many, he's an inspiration and a musical genius. To me, in this presentation, he's been the source of some jokey, punning chapter headings and a little quote at the end. So the timing has been, with retrospect, a little bit unfortunate, but there was no disrespect intended. I'm talking today about something which is really quite close to my heart. The making of objects and the knowledge that we have about the making of objects. I'm going to talk about its importance for the human race. I'm going to talk about its importance for our culture, and I'm going to talk about its importance for our projects. And I think that it offers an opportunity for us to improve our projects further. So, the human race. The director of the British Museum thinks that the invention of the first tool is one of the most important moments in human history. The tool he's talking about comes from here, in East Africa, where the human race was born. Our first ancestors lived here 1.8 million years ago. The tool that he is talking about is this stone chopping tool. It's a very simple thing. It would make a good weapon, wouldn't it? It would allow you to prepare food or make a shelter. It allowed our early ancestors to survive. It gave them an edge in their environment. As time went on, yeah, that was a pun. As time went on, the technology, the knowledge of how to make these tools improved, and our ancestors developed the craft. As they learned how to make the tools, it developed and became better. This stone axe is about 1.6 million years old. It's a much more sophisticated thing. It allowed our ancestors not just to survive, but to start to thrive and move out to colonize the rest of the world. By 1.6 million years ago, you're finding these kind of tools in Asia and in the Middle East and in Europe as well as in Africa. So we can see that the knowledge about how to make those tools is one of the things that has allowed our species, the human race, to be successful. If they hadn't known how to make those axes, then we might not be here today. So that's the human race. How about culture? I want to talk to you about three of my heroes. Another pun. Thomas Telford is the first one. He is arguably the first civil engineer. He was born in 1757, the son of a shepherd. His father died at an early age, so he was apprenticed to a stonemason. He did very well at the stonemason business, and he became a civil engineer. He was responsible for designing many bridges, hundreds, from the smallest culvert right up to the suspension bridge at the Menai Straits. He designed road networks, including the roads in the Highlands of Scotland. They were the first roads in that area which were passable to wheeled traffic. One story which caught my eye particularly about his design of those roads was how he decided on the gradient to make the roads. His knowledge of the stonemasonry business and moving things around meant he knew about horses and carts and carriages, so he measured the force that the cart exerted on the horses on various road surfaces, and he decided on a maximum gradient downwards so that the cart wouldn't run over the horses. He used that maximum gradient, 1 in 30, for all his roads. So you can see here, just in this picture, that the A5 in North Wales is going round the sides of the valley to achieve a nice smooth gradient. This is something which is an essential part of road building these days. It was unheard of at that time. My second hero is a road user rather than a road maker. He was a racing driver in the 1930s. Here he is at the wheel of the car that he drove. He made this car himself without the use of power tools, apparently. Not quite sure why, but that was how it was, the lightweight special. He was quite successful as a racing driver. This knowledge of building cars and making them came in very handy later on when he was designing the Mini. He was able to take existing components, the A-series engine and the gearbox, and use them in a new way by arranging the engine sideways between the front wheels and folding the gearbox round underneath. This made the car much more roomy for the passengers and smaller on the outside. This was kind of unheard of at the time, but now it is the standard configuration for cars. Most of the cars on the road use this arrangement of engine in the front, driving the front wheels. My third hero is another maker. George Martin was the record producer who worked with the Beatles in the late 60s. When the Beatles decided to stop touring and make a studio album, they brought the musical genius and the snappy lyrics and the pop culture, but George Martin brought a knowledge and a practical understanding of how to make recordings, how to use the technology that was there at the time, using tape backwards and making loops and overdubbing, and also doing musical arrangements as well. His partnership with the Beatles allowed them to make a new type of music. They created in the Sgt. Pepper album a new palette of sounds which musicians could use for creating music. He took a step forwards in the culture of popular music at the time. All of my heroes here are people who had practical knowledge of how to make things. They used that knowledge to gain success in what they were doing, and it wasn't just a kind of ordinary level success in these examples. They added their special imagination and ingenuity and moved their area of endeavour on to a new place. So that's how making is important for our culture. What about our projects? I think we all know of projects where the practical knowledge of how to make buildings hasn't been applied in the design process. This example comes from a friend of mine, thinks this is very funny. He is a steel erector and he now has built the 2012 Olympic Stadium and the Centre Court at Wimbledon. At the time, in 1995, we were working on the Cribbs Causeway Regional Shopping Centre in Bristol. Somebody in our design office had designed this arrangement of beams, and he had to build it. Trouble was, beam A here, you see, that rests on beam B, so beam B has to be in first before beam A can go in. Beam B rests on beam C, and beam C in turn rests on beam D. Beam D is supported by beam A. We had to redesign that piece of steelwork, and he built it, and we all moved on, and that was fine. At the other end of the consequence scale lies the Wembley Stadium project. You'll remember the coverage it got in the media at the time. I wasn't involved, and I don't know the rights and wrongs of the situation and who was at fault. But if we look at some of the things that were said in the media at the time, I think it's pretty safe to say that if there had been input from somebody with a knowledge of the making of the building, a knowledge of the practical aspects of construction at the design phase and in the planning and tendering phases on that project, then the project would have gone better than it did. We could imagine, couldn't we, a scale of the negative consequence of a lack of practical knowledge of construction. And wherever our projects are on that scale, even if it's right at the left-hand end, there is a cost and a time that a disadvantage that could have been avoided, and we want to avoid that. That's a risk that we want to control. So that's a negative aspect of not understanding making properly. There are some positive aspects too in projects that we work on. Chizik Park is a particularly lovely example of a continuing process of improvement in a project. The park has been built out in a series of 12 buildings, each one built by the same team, learning from the construction of the last building, making the construction more efficient and faster and less risky each time. There are a bunch of technical solutions which the project team have included in the building, and I'd love to tell you about them sometime later. They have not only done what they set out to do, which was to build buildings which were economical to build and fast to build. They've also created a place which is very attractive and people enjoy working there, and it's sought after by tenants. So, big success story. Another success story, and this one's close to my heart because it's a tall building and my specialism is in tall building design, is Heron Tower. Here we used an integrated design worked out with the construction in mind. It uses a top-down construction process for the basement. So you start building at ground floor level and do some piling, then start building upwards with the tower while the basement goes down. The good thing about this particular, and that saves you 6 months in the construction time. This is a big win on the economics of building the building. The other big wins about this design is that it doesn't include a heavy central core. The stability systems in the perimeter of the building, so the internal columns, which have to be plunged columns to make the top-down basement work, they are very light and simple. So that saves money. And also the timing of the construction means that you get to the basement floor by the time you're at level 32 and the main loads haven't come onto the building yet. So you can use that basement floor not only as a floor for the basement, but also as a great big foundation. It becomes like a really big pad footing and means that the piles can be relatively small and inexpensive because they only carry temporary loads in effect. So that's a good gain from an integrated design. The Sagrada Familia project as well is one that is it's very close to my heart because I'm working on it at the moment. We are working with the team from, and in very close collaboration with the team from Barcelona, the builders and the architects and the engineers in Barcelona, to build the towers that they'll complete Gaudi's design and take it up to 176 metres above the datum level. They had two particular challenges which they needed to overcome. And that was the weight on the foundations, which were started in 1882, before even Gaudi was involved in the project, and also the kind of temporary works, scaffolding, temporary supports that they would need for the towers. What were they going to look like, and how expensive was that going to become? The solution that we came up with them involved building the towers stage by stage. First, you put up a ring of steel columns, then you slot in between them some pre-stressed masonry panels which bolt into place between the steel columns, and that makes a complete composite structure at that stage, and then you infill the gaps at the corners. Here's one of those panels. This is a sort of structural diagram. The stone is very strong sandstone and granite. There's a mixture in there, and it's held together with pre-stressing tendons made of stainless steel. They pre-compress the stone, so they hold it in a structural block. The resulting structure has a similar kind of strength to reinforced concrete. It also forms the finished internal and external surface of the towers. So here you can see one of those panels in a mock-up being lowered into place, and a final little thing that we have done as a project team is to arrange the connections so that in construction, when they are building it on site in Barcelona, it slides into place and it has only one location that it can go into. The connections are designed so that it fits first time and there's no adjustment. So there are some examples of why making is important for our projects. I'm going to suggest to you today that it would be advantageous to us to change the way that we organise our projects so that that can happen more. Like Alekis Ingonis and George Martin and Telford, you can see the Mini there is driving down a section of the A5, which is one of Telford's road. Like them, if we have knowledge of making things, we can use that in our projects to produce something which is not only a success, but also moves the technology on or the culture on to the next level. There's a big opportunity for benefit there. How will we do that? In 1998, Sir John Egan published a report, Rethinking Construction. He wanted the construction industry to change and work together to create a modern industry ready to face the millennium. That was a little while ago. I've written his ideas here as 12 commandments on tablets of stone. There are some very obvious things in there, like increasing quality and reducing errors. There are also some more radical things that come out of this. You would ideally organise your project as a partnering contract where the suppliers and the designers and the client all have an equal share in the success of the project and work in a non-adversarial way collaboratively to make it work. That's a big deal and that's a big contractual change. Is it feasible? I think it is. We built Terminal 5 in this way. I led the design team which designed the roof and facades of Terminal 5. We built it as a partnering project with the steel suppliers and all the other suppliers, the roofing suppliers. We built a project which was tuned to work with the way the suppliers wanted to manufacture and erect the building. We produced a project which ended up on time and on budget. And at the same time as doing all that, we produced a project which was successfully architecturally and successful for the client. Jonathan Glancy said it was one of the most breathtaking man-made spaces in modern Britain. That's pleasing. Should we then make this revolution in our industry? I think we could, but I also think that moving on by evolution is almost always better than moving on through revolution. There is a big obstacle to overcome, and that is the worry that if you lock in your design at an early stage to suit a particular supplier's method, then they're going to take you for a ride later on and hold you to ransom on price. To get over that, we will have to change the way that our project teams behave. Plato reminds us that to do that, we will need to engage the emotions and the desires of the people on those project teams. I've written some 5 commandments to talk about that. They're not commandments at all, really. They're just my thoughts. I think the key to this is to give the key people on the project personal ownership of the success of the project. People who are making decisions and making design decisions and leading organisations need to feel that the success of a project for the client will also lead to their success personally. You might do that, for instance, through developing long-term relationships. Somebody who knows that if they put in a bit of extra effort now to fix a problem or overcome an obstacle, they know that they will be getting the next job and the one after that, and it will further their career and it will be good for them. That person is somebody who's going to work for you on your project to make that project a success. The whole project team also needs to have a bit of a change of way of thinking about profit and success. I think we all know in our hearts that for a project to be successful, everybody who's working on it needs to make a profit. We often don't behave in that way in our project teams, do we? Clients and project managers need to communicate the fact that they understand that the suppliers need to make a profit. If the suppliers understand that, and the suppliers also need to understand that the client and everybody else needs to make a profit as well, that will enable mutual trust to develop, and everybody can move together collaboratively. This may well end up with negotiated contracts rather than doing lowest price tenders and picking the cheapest person to do the job. If the Beatles had picked the cheapest producer for the Sgt. Pepper album, we wouldn't have music today, which is the same as we do have. So I think that this may be strange for some of us, mightn't it? But I think it's important to take on board. But anyway, that's not really the main point of what I'm talking about today. I don't want to recommend a particular contractual arrangement. You could use a full partnering contract. You can use long-term relationships like at Chizik Park. You can do PCSAs. You can employ people in the design team who have personal knowledge of making, and they can make a difference to that project. The point is that it is important to use that knowledge and bring it into the project team and use it for the benefit of the project team. Then, like our heroes, Telford and Isigonis and George Martin, we may be able to not just make a success of our projects, but also there's the opportunity to make the next step and produce something that nobody had even thought was possible. Thank you. Do you have any questions? Ed?
Steve, what do you think is the next step in terms of the way we make buildings, in terms of construction?
Now, well, there's a good question. I don't really know. The thing that I like to do is to look at the project and what it needs and the ideas that are available, and you know, the opportunities for making the ways that people want to work on that project, and to devise a solution that works for that project. You know, at Sagrada Familia, that turned out to be something that was really quite unusual. We're using masonry, and we're doing off-site prefabrication, and we're pre-stressing masonry, and this is something that's hardly gets used at all. On other projects, the most important thing to do will be to use a very deliverable technology like a concrete slip-formed core and lovely post-tension flat slabs and precast columns, and to do something, you know, maybe like Chizik Park or like the tall buildings that we do that can be delivered efficiently and quickly. I don't know. It's for people to have ideas when the need is there.
Hi. I work with Arup. I wondered, how do we get better at making? Because I think you've demonstrated how we can benefit from it, but how do we get better at it as engineers? Because
As engineers, I think a key thing, as design engineers working at Arup, for me a key thing is to listen to people who do the making. An important moment on the Sagrada Familia project was when I took the guys from Barcelona, because they use concrete a lot, they use stone, they're not very used to using steelwork. So they were worried about their ability to screw in small spaces. They were worried about doing up the bolts when there was limited access. There's a language thing there as well, and sometimes the emails say surprising things in them. So we took them to see the Emirates Stadium project, and John was there, and he talked about lifting large pieces of steelwork in place and how important it was to be able to line up the bolt holes, and how that was a key thing. And that's where we came up with the idea of doing these fit first time connections that would automatically align the piece as it gets lowered into place. So it's about listening to people.
Yes. There's talk of the institutional engineers down-rating the requirement for site experience to get qualified. Have you got any comment on that?
Oh, I think it is utterly essential for us as engineers to have practical experience on site. I would want almost anybody that I employed to know what they were doing and to have that experience. I think it's daft. I'll do what I can to change it. It'll only be a small thing, won't it? But yeah.
Yeah, my comment was quite similar actually. I was curious about whether you think the way that we develop engineers kind of leads still to this the kind of innovation and the kind of sort of imaginative, unconventional thinking that you're sort of suggesting is necessary as part of the process, or whether we risk sometimes becoming a little bit too samey in the way that we deliver projects, and we kind of lose that imagination by needing to deliver things too quickly under too much pressure. We don't give people the...
It's very important to develop, I think it's very important to develop our people and to expose them to a whole range of different inputs. The making thing is a very important one, and we need to learn from contractors and suppliers and from real site experience. It's also important to understand, and for our people to come to understand, the drivers which are important to our clients and to developers, and the drivers which come from architecture and from making buildings for people. So we have to give our people a range of experience and expose them to all sorts of different stuff if we want to produce really successful projects. Has anyone got more questions? Thank you.
I thought it was a great talk actually. It's one of the best talks I've seen. And yeah, I really like the way that he was talking about engaging with contractors from a contractor point of view myself, and clients. It's so important to make sure that the end users, you engage with them and understand what they actually want, how to build. It's not one particular approach for any particular building. It's really very dependent on the contractor, the client, where you're going to build it, and all these different factors. It's very bespoke. And that's what I love about building buildings.
I liked it. I liked his homage to David Bowie. I thought it was appropriate. He's clearly a fan, and I am too. And I thought it was well structured and thoughtful. Yeah, they're long in gestation and they need to develop more and quicker. He's completely right. It's all about partnering. The key person in any partnering is the client, and to have a good client, and that is the client who not only pays their bills but also leads the team, is vital. I think that individual engagement and personal responsibility for a collective endeavour is absolutely critical. Without that, then there's not proper engagement for the project team as a whole. And it goes back to what I said earlier. The client is the person that guides that, drives that, allows that to happen. And the form of contract, the form of association, the form of relationship, the way that suppliers can be brought in, the way that their specialisms can be brought to the fore, because a design process doesn't just happen at a what was used to be a drawing board, now is a computer screen. It doesn't happen there. It begins there. Conceptually, it begins there, and then it evolves all the way through the project and becomes something that is a collective endeavour. You can look at any building site. There's thousands of people involved in the construction of any building on site, and all of those people have a part to play and a big role to play. And so collective responsibility and the engagement, personal engagement, is critical.
It definitely meant a lot to me of quite a few things that I think many of the people in the audience were thinking about. I mean, the big leap of faith, I think, of understanding by all the people involved that profit isn't a dirty word, and that ultimately that's what everyone wants to make, and for it to be a success that everybody should be entitled to make it. I think that will be always the biggest issue to get through a lot of people, where the last 4 or 5 years of really hard competitive tendering means that prices haven't been reflective of what the real cost of the industry is, and hopefully the next 5+ years we're going to get back into some kind of normal business resuming.